I'm excited to announce or to introduce our fourth session here and our speakers for this session. This session is the Sustainable Toolkit about standards, ratings, and design strategies. Sustainability is not just a material attribute, it is a design parameter that intersects with every part of the structural workflow. This session connects the dots between high-level design strategy and ground-level technical compliance. We will explore how to leverage structural efficiency to meet increasingly stringent rating systems like LEED v5 and how to confidently specify novel materials within the safety net of current ASTM standards. Please join us to learn how to weave these technical requirements into a cohesive design approach that satisfies both the code and the climate. We have 3 speakers for this session. Our first speaker is Larry Sutter. He is a principal of Sutter Engineering, providing consulting services on concrete making materials. He is a professor emeritus in materials science and engineering at Michigan Tech University. He specializes in supporting implementation of alternative cementitious materials and supplementary cementitious materials. He's a fellow of ASTM, vice chair of committees of the cement and concrete committees, and holds numerous leadership positions, including chair of the subcommittee C09.24, supplementary cementitious materials. He is a fellow of the American Concrete Institute, holding multiple leadership positions, including chair of committees on durability code and durability. He's a registered professional engineer in Michigan. Our second speaker is Jacob Savona, who is a sustainability manager who helps lead Consigli's efforts to reduce carbon emissions across the built environment, with a focus on embodied carbon tracking from pre-construction through project completion. His work supports both project-specific goals and company-wide commitments like SBTI, while also advancing green building certifications and sustainability best practices. He's passionate about integrating low-carbon strategies that deliver meaningful environmental and business outcomes. And then our third speaker is Jordan Woodson, who is an associate in Arup's New York office, where he excels in providing innovative structural solutions for design-focused projects. Woodson has been with Arup over 13 years, delivering structural design for a diverse array of building typologies and materiality, including commercial and residential high-rises, band shells, airports, and sculptures in steel, mass timber, and concrete. Driven by technical excellence and design innovation, Woodson is a frequent collaborator across Arup's offices, assisting in design reviews, project delivery, and staff mentorship. And with that, I'm going to hand it over to Larry to get started with the presentation. So bear with me 1 second while I pull up our slides. And Larry, I'm going to hand it over to you.
Okay, thank you. Can you hear me?
Yep.
Okay, good. All right, so I'm going to give you just a brief overview of some of the, as the title says, some of the tools to work towards sustainable concrete and some of the changes and specifications and test methods that support those new materials. And so obviously there's this whole afternoon has been talking about reducing the carbon footprint of concrete, and it's of interest to a number of stakeholders. And of course, we want to do that while maintaining structural integrity, durability, and resilience. So we can't throw out the baby with the bathwater, but there's a lot of things that we can do. And we have to realize up front that that might come with changes. It doesn't necessarily have to come with changes. We heard a great talk before the break about how cost and schedule were able to be maintained, and those are really key points to consider. But not always is that the case, and sometimes there might be something that we're going to have to give up to get what we need. But the good news is, in my opinion, we do not have to sacrifice performance of these materials. Next slide. So how do we get there? Well, we need to look at what our options are. And our options, very broadly put, are really twofold. And that is, number one, to avoid the use of Portland cement, or to substitute something in place of at least the clinker fraction of Portland cement. And through those two steps, we can really make some meaningful changes in the carbon footprint of the material. So why the cement? Next slide. Well, this is a slide that maybe many of you have seen in other presentations. It's not it's common, but it kind of, I think, in my opinion, crystallizes the problem. And if we look at concrete and cement, for that matter, we really are in kind of a low carbon environment already. So I always like to use the phrase lower carbon rather than low. But at the end of the day, we use 4.6 billion tons of cement a year on this planet. And we take even a small number, which is the carbon footprint of these materials, and multiply it by 4.6 billion tons, we have a problem. And cement does result in significant carbon production. You get approximately a ton of CO2 per ton of cement produced. So we have to, acknowledge that that's a fact. And the bottom line is that the majority of this carbon comes from the reduction of cement, 89% from production of cement. So affecting the cement is where we're going to make changes. Next slide. So what are we going to do? Well, this is my mantra: less clinker and cement, less cement and concrete, less concrete and construction. So in the cement, we can replace the clinker with something else. We'll talk about that in a moment. In the concrete, we can replace the cement with something else, which is typically aggregate. And then we can look at how do we just reduce the use of concrete, period, across the board, which is optimizing designs of new mixtures and using alternative materials. Next slide. So we talk about new materials. Here's one example I like to use. This is two structural members, one on the right made with ultra-high performance concrete, one on the left made with conventional concrete. Ultra-high performance concrete probably has 3 to 4 times the cement that we normally see in concrete. Well, at least let me say 2 to 3 times the cement we normally see in concrete. However, we use a quarter of the concrete to make the structure, so the net result is approximately 50% reduction in cement. So these are two structural members that perform the same. Less cement and concrete, we're going to get that through proportioning differently. We need to look at optimized ways of optimizing the concrete mixture, get away from the conventional methods. Next slide. Typically what we do is what's called the absolute volume method. When we do a mixed design, we fix the water content, and then we basically vary the water cement ratio by varying the cement content. We hold the aggregate constant, we vary the sand to compensate for the cement. We throw in an over design to meet the 301 requirements, and that's our cement requirement. Next slide. And so what we end up with is we're increasing this cement content by 100 pounds to adjust the water to cement ratio. And of course, strength is increased as we decrease the water to cement ratio, and permeability is decreased. But we're doing it by increasing the cement. We're not acknowledging any of the current things we have at our disposal, such as water reducers and optimizing the aggregate gradation. Next slide. And if you look at this idea, I mean, this plot here is just done from National Ready Mixed Concrete Association. These lines, each of these lines on a plot are showing a constant water to cement ratio, but then increasing the cement content to get there. And you can see as we change the cement content, we really don't see much change in strength. What we really want to do is change the water to cement ratio. So we can get there without changing the cement. And of course, the big thing that we never talk about is testing, over cementing to pass the test. And in the interest of time, we'll come back to that some other time. So next slide. So less clinker and cement is the option. So what are we going to do? We have to replace the clinker with something, so we turn to SCM, Supplementary cementitious materials. That's our first line of defense. And we can do that in blended cements, or we can do that at the ready mix plant. There are alternative materials that are coming our way. Those materials are still, at least alternative cements are probably 5 to 10 years out. But alternative SCMs are currently available, and we need to start looking at those materials. Next slide. So how do we get there? Well, the first thing we got to do is look at new tests that are going to help provide us information we need. And so we do have a couple new tests. We've developed C1897 for measuring the reactivity of SCMs by calorimetry or bound water. And this is a completely new approach to estimating the strength contribution of an SCM. And the testing correlates quite well with compressive strength of test mortars. And then an even more recent test is C1952, which has just been recently adopted, which measures the bulk resistivity, which again correlates with compressive strength, but more importantly, correlates with durability. As we reduce that permeability, we improve the durability. So this 1952 is a new way to assess the impacts or contributions of an SCM where we've never been able to do this before. Next slide. In terms of new specifications, we have C1912, which has just recently been published. It's a performance specification for SCMs. There's no limits in compositions. We do specify the reactivity, as I just mentioned, but it gives us a pathway for new materials, emerging materials, but also for existing materials that maybe don't meet the existing specification, but they're still very usable. We've developed a new specification for natural pozzolans, building off of the old C618 Class N, adopting some new test methods, again, to measure reactivity and other important properties. We have a specification now for ground glass pozzolans, which allows those to be used, and I know they've been used in a number of different construction projects successfully. And then we have the existing 1697 for blended cements, which we are modifying to allow for a broader range of blends to be used. Next slide. In terms of cements, we've developed a new specification for alkali activated cements, C1948. This addresses cements that people commonly refer to as geopolymers, although I don't know if there really is such a thing as a geopolymer, but that term is used. But it's alkali activated. It's not a hydraulic cement. We now have a specification to address those cements. And those are typically used under different curing regimes, and so the specification addresses that. Another important specification is C1905. This is for cements that require carbonation curing. There was a product in the past called Solidia, which fell into this, but there are a number of other products that are being used for producing concrete block. And this specification covers those cements and allows us to use those techniques for making concrete block. And I would draw your attention also to the ICCES acceptance criteria for low carbon alternative cements for use in concrete. It's published, it's out there, AC 529. This gives you a tool to do the acceptance testing for using these materials in a 318 design. Next specification, or next slide. C595, this is a blended cement specification. We've made many changes to this specification over the past couple of years. And there's a number of changes that have not yet published. We're waiting to coordinate the publishing with ASCE, but the changes have been approved. And basically, probably the most major change is that we can allow now up to 15% limestone in what we refer to as a type 1P, a pozzolan blend, and a type 1S, a slag blend. Typically, in the past, we've only allowed 15% limestone in a type 1L cement, which many of you, I'm sure, are familiar with. But now a 15% limestone can also be in a 1P or a 1S. And we've also allowed 15% limestone into a ternary blend. And that limestone does not count as a blending component. So it's 15% limestone plus either two pozzolans or a pozzolan and slag. These are important changes. These are materials that are in the marketplace right now today. 1Ts, 1Ps, 1Ss are in the marketplace. Please go back one slide yet. And they're in the marketplace today and they're being used. And so this is going to be a major change that's coming our way. Another type is type 1C. This has been approved. This addresses a new cement type that many of you probably have heard of, the LC3 cements, which involve limestone, clinker, and calcined clay. And the 1C is going to allow 70% of limestone, pozzolan, and slag in any combination, with the only limit being on limestone at 30%. And then the balance would be cement. So basically you have a 30% minimum cement. Next slide. And this slide basically summarizes these in terms of, probably most importantly, of the clinker content. The black bar indicates the cement content. So moving up from the bottom, your typical type 1, C150 type 1 cement, 95% cement. And it'll move up a 1L, 85% cement, a 1P, now 45% minimum. And then the 1Cs and the 1Ts. And the 1Ts in particular, I want to draw your attention to. The 1T cements, I think, are the low-hanging fruit. That's where we can really start doing things today with the materials that we're using today. in proportions that we're used to using today. There's really nothing new here. We're just using them in different combinations. And we can get down to 30% cement if we want to with these types of blends. And of course, we move into the slag blends or the 1T blends with high slag content, so we can actually have no Portland cement in those mixes, all the way up to the C1157 cement, which is the performance specification for cement, which would allow no cement to be used, but many other things could be used. Next slide. So some resources for you to look at. Low Carbon Concrete Guide, Don Davies and a group of individuals, including myself, put this together. A lot of good case studies, a lot of good best practices. And then just for some very general information on codes and standards and other information related to this subject, the document on the right is something we put together a couple of years ago. The standards have changed a little bit, but the basic concepts are still there, and it kind of gives you the lay of the land with some action items to pursue. Next slide. And with that, I thank you for your attention.
All right, good afternoon, everybody. I'm Jacob Savona. I'm with Consider Construction Company. I'm a sustainability manager here. I've been in this role for just a little while now, but here to talk about LEED, ILFI, and everything in between here for embodied carbon. So as you know, building materials and construction make up around 11% of our emissions, global emissions by sector. And so that's why structural embodied carbon is so important. The impact of structural embodied carbon, as the grid greens, will basically, take up more and more of the source of carbon in our buildings. And as you can see from this helpful diagram from a CLF, recent study in CLF as-built buildings, the structure of buildings based on a variety of different building types do make up a big chunk of our embodied carbon. So I guess diving into the different requirements for different sustainability certifications is first and foremost, which is out here now, just LEED version 4.1. This is just strictly a credit. You can conduct a whole building life cycle assessment. You get a point just for doing it, 2 points or 2 to 4 points basically just for reducing your embodied carbon, along with other impact categories as well, 5 to 20%. But the 20% you do also need to incorporate some kind of salvage material, bio-based material. So that's not really something that we see typically, but you see 1 to 3 points on most projects. But now there's LEED v5, next slide, that kind of breaks this one credit out into kind of a prerequisite and 2 credits. So the prerequisite is basically asking you again to kind of run that LCA, but then making sure that it includes your structure enclosure and now hardscape materials, and then identify some hotspots in your building. You don't have to do anything with those hotspots, but just kind of identify and probably starts a conversation around what you can reduce feasibly on your project. And then it breaks it out into 2 credits. So one is the reduce embodied carbon credit by doing the whole building life cycle assessment, and you have to demonstrate just GWP reduction, so your embodied carbon reductions according to a baseline, by 0 to 40%. So that's 2 to 6 points now instead of 1 to 4 points. And you have to do a 20% reduction at least just for platinum buildings. There's another credit under the reduce embodied carbon credit, another approach, rather, where you can do a product average approach or a materials type approach. So you're procuring kind of low carbon materials and you have EPDs and you're tracking all of that as well. And as long as you're showing, the products that you're sourcing are lower than the industry average, you can get anywhere between 1 to 3 additional points. But overall, that credit is just up to 6 points. So LEED is really leaning into embodied carbon. ILFI, which is becoming more popular on a lot of projects that we're seeing, just because of how they kind of break things out here. There's whole different types of certifications. There's Living Building Challenge, there's Zero Carbon certification, there's Core Green, and then there's pedal certifications as well. So kind of going down the list, I won't go into each one in too much detail, but a big common theme is kind of setting this impact to 500 kilograms of embodied carbon per meter squared of the building. So setting that kind of like carbon budget in your building. And then for, I guess, 2 of the certifications, you do need to offset 100% of your embodied carbon. So you have to purchase some sort of, carbon offsets for your project. And then for, I guess, 2 out of 4, you do need to show reductions. For Living Building Challenge, you need to show at least a 20% reduction. For Zero Carbon certification, it's 10 to 20%, 20% for new builds. And the other 2 are just kind of reporting only, depending on the pedal certification that you choose. But this is more of an all or nothing compared to LEED, and that's why people tend to kind of go towards ILFI, where like, you have your budget, so you can kind of hit this budget, you can hit these reductions in any way you see fit for your project. So that's why we see some clients kind of go more towards ILFI versus LEED. So what works with our projects and with LCAs and things like that? So first thing is early stage benchmarking, right? So you probably heard this a lot, but like the more you do SD to DD analyses, the more you can actually work with your structure and work on what actually works in terms of cost and what actually works in terms of optimization. Next is digital integration, so utilizing your tools that you have to kind of easily export your bill of materials for your projects and actually use those bill of materials for your whole building lifecycle assessment. A big point of I guess pain point for whole building lifecycle assessments is actually getting the usable bill of materials and all those quantities and assigning EPDs to all of those quantities so you can actually produce something that's usable and actually use that data to showcase reductions. The last is a functional unit. So basically, you probably heard this as well. Defining your structural system itself as a unit analysis. So you're fairly comparing one structure to the next. So it doesn't work, obviously, is not waiting until the last minute, right? So we don't want to be conducting LCAs and CDs if we can help it. At this point, you're just kind of like just conducting an LCA just to report carbon, which is also good, but there aren't too many options for reducing your embodied carbon in your building. Again, try to do those early stage LCAs as much as possible. Defining your system boundary is super important, depending on the sustainability certification that you're going for. LEED and ILFI do have different kind of boundaries where ILFI, kind of sets it around A1 to A5, where like LEED is a, cradle to grave type of situation. So identifying that, defining it, making sure everyone understands what's actually being reported is really important. And then prescriptive-based specs, you've also, heard this on other, presentations here. So setting limits to your SCM content doesn't really allow for too much flexibility in procuring, I guess, cost competitive. That's what we're kind of interested in the construction space. So cost competitive, low carbon concrete, and making sure that actually works with the schedule for your particular project. Next slide. Yeah. So from the contractor's perspective, you also heard this on another slide, but there is kind of a green premium myth going around, and sometimes if you ask for low carbon concrete, you might get just a higher cost just because you've asked for low carbon concrete, not necessarily because the concrete is actually cost more. So you can be asking for low carbon concrete, ask for those EPDs, making sure you can actually get that on your project. The risk really isn't too much of the cost, kind of depending on what you choose. But scheduling is kind of that risk and the lead times, and making sure you can actually procure that concrete is more of the risk. Though there are still obviously emerging technologies that are always like cost prohibitive to particular projects. But the more they get used, the more they become industry standard. Procurement gap. So requiring EPDs in your specs is super important. As a CM, as a contractor, we can only do kind of what's in the specs. We do have to. We're trying to work on implementing policies to make sure that we do actually require EPDs for particular materials, particularly concrete. And also steel, just because they are out there. You can see that in this DC3 screenshot, right? It's like just for Massachusetts, there's over 1,000 EPDs you can choose from. In the United States, there's over 99 EPDs for structural steel. So they are out there. You just have to require them on your project, and it's okay to actually do that. We've heard it makes our lives a little bit easier. And then also like, innovation, right? It's like using mass timber or high fly ash mixes. There's different like cure times to that. There's different bracing sequences, and coordinating early on as if you can, right? It's kind of depend on your project, but coordinating early on with our CM to account for all these like scheduling impacts of these different decisions is really important to ensure a successful project. The next slide, yeah. So opportunities for structural engineers. I really like this image from a Borough-Hatfield study that was done, I think, out of the UK division, but it shows kind of like this material efficiency and that is like available to a lot of projects, right? It's like you can start with a certain type of structure, and there's also different material efficiency approaches you can take. most projects are unique and they're also not unique at the same time. So you can sometimes apply these approaches to one project or maybe not to another, but it's always important to kind of run through these, optimization strategies specifically just for, embodied carbon. And then looking at salvage materials, I think it's super cool to see a lot of stories around, projects looking at buildings and saying like we can reuse the steel and actually reuse that steel in the same project or even, use it on a different project. I think that's really, that's a great opportunity. And I think that's going to be more and more of an opportunity going forward. And then also kind of going back is performance-based specs, right? Shift from requiring specific SCM content in your concrete or recycled content in your structural steel and more specified towards a GWP limit for kind of like the whole structural system. So talking about the whole concrete on your project or even the whole structural steel on your project. And then that allows us as CMs to kind of work through that a little bit better and be a little bit more flexible, like what works with our costs, what works with our schedule, and we'll be able to work through that. So what's next? Early integration of sustainability, obviously, is your only assurance against late stage designs, redesigns, and procurement failures that can happen. And then also in your next project, require product specific EPDs for every ton of steel, every yard of concrete, anything that's in your structure. You can require an EPD for it. If it isn't there, that's okay. You can just work through that. But if it is there, we do not want to miss that opportunity. And also sign up for the SE 2050 commitment. Thank you.
Great. I'll go ahead and jump in. I'm Jordan Woodson. I'm a structural engineer with Arup. I currently lead our structural engineering team across the East Coast. And what I want to talk about is sort of builds nicely on some of the previous presentations from Robbie and what Jacob was just saying. Trying to create a design methodology for how we can start accounting for carbon in our structural work from the very beginning and really owning this piece of scope appropriately. So at my heart, I am a structural engineer and I've sort of backed into the sustainability space. And I want to highlight, so just a few projects I've been engaged on where we've treated carbon as a design tool. This is National Geographic, their new Museum of Exploration in DC. If you go to the next slide. It's a project called, it's a new headquarters for the bank Ban Bajío in León, Mexico. And if you go to the next slide, a University of Michigan Center for Innovation in Detroit. And so all three of those are unique projects. And you'll note not one of them has timber, but we treated each of them as a unique opportunity to design for carbon. And I think everybody on this call is aware of sort of like the typical tools of our trade of what we can do as structural engineers to reduce carbon, build nothing, build less, build efficiently, use less cement, explore alternative materials. But I think sometimes that offers us, can be challenging to give to structural engineers, right? Not all of those options are available when we're brought onto a project. So how do we start thinking differently as we start to design a project and design a building with carbon in mind that isn't just a checklist or a list of rules of thumb? So if you go to the next slide, I think it's really important to demystify embodied carbon and note that it is a calculation of our quantities times factors. And if we can get pretty good factors, we can use carbon throughout our design process, just like we would use cost if we were given cost data as much as we wanted. And it would be the responsible thing to do, right? So we all know quantities well. And so the benefit is if we're able to get factors, which SE 2050 has worked tirelessly to give us, then we can start being really good at optimizing for carbon as well and using it as a design input. And if you go back to that equation of its material quantities times the GWP factor, I like to break out that's generally how our industry has approached structural engineering for sustainability. If you go to that next slide now. On the left-hand side, you kind of have like a typical structural engineer's old school approach to being sustainable is I design with the least material necessary. I'm a quantities focused designer as always. and that is the sustainable option. And then you kind of have this newer school of thought, which is very materials focused. It's really looking at low carbon materials, use of timber, low carbon concrete, et cetera. But you're not going to build the cheapest building by buying the cheapest materials. You want to be at that integration of the two, right? We want to find the design opportunity that lives at the intersection of both quantities and carbon factors. And that's where we've started to explore how we approach design within Arup. If you go to the next slide. So I think, Jacob just shared the exact same plot. This one's from OneClick. But if you look at the typical opportunities that are available to us in a design process, most of the carbon reduction can happen early in the process. This has been hammered home by a lot of previous presenters. But if you looked at the actual sort of implementation of LCA and how it's being applied typically on projects, if you go to the next slide, we're sort of selecting systems very early in the design process, and a lot of LCA doesn't happen until we have a Revit model of that selected system. And then we go and procure it, and then we do another LCA to tell us what happened. But what we want to be doing is evaluating for carbon throughout the process. We don't want to wait until we have a Revit model and locked in systems. We want to be using evaluation for carbon throughout the design process, rather than, sorry, if you can go back. We want to be evaluating for carbon throughout the design process and not just picking discrete points to say, here's where we are, and we think we did the right thing initially, but we actually have no way to compare that to what we were studying against. So trying to use carbon as a design measure throughout the design process. And we've done this on a lot of projects and have a lot of different case studies. I think in the interest of time today, I'd like to just focus on one thing because it's been a sticking point for me over the last 5 years, and that's slabs on metal deck. So if you go to the next slide, I think availability of carbon data and getting that in the hands of engineers is really important. And when we do that, we find a lot of opportunities. We open structural engineers up to start solving these problems through their typical methods. Again, if you think of carbon data as like cost data and you give that to engineers, engineers are going to know how to optimize for cost, rather than just saying, I gave you the least quantities. And we want to be doing the same with carbon. And when NRMCA data was released, to me, it was shocking to see lightweight concrete has 80% more carbon on the East Coast of the US than normal weight. And as someone who designs a lot of steel buildings, that was like a huge flash in my head to be like, do we need to be using lightweight concrete, and does it actually make sense? So if you go to the next slide. What I did is I looked at a 40-story or 20-story building that would sort of be a typical office building anywhere in the US, sort of ignoring foundations and cores, just looking at gravity systems, and then using Ecom and SE 2050 data, sort of looked at where the carbon was in the building. And it's a steel building, but shockingly, 43% of the carbon of that gravity system is in the concrete slab, and 24% was in the metal deck. So that told me the best way to optimize for a steel building is not to focus on the steel exactly, but to focus on the topping slab that we're using to get composite action. And this was with using lightweight concrete 3¼ over 3-inch metal deck as the basis of design. So if you go to the next slide. And so we question then, why are we using lightweight concrete? And I think the answers are evident in practice from the last 20 years, right? We use it to reduce the self-weight of the building. You need less lightweight concrete than normal weight concrete to achieve a 2-hour fire rating. And that's usually the basis for how we pick our slab on metal deck, is what gives me a 2-hour rating. And then there's also this assumption that SFRM, or spray fireproofing on the deck, is costly or labor intensive or just gross visually. But if we're thinking of carbon as the driver of what we need to be doing structurally, we should open that question back up. If you go to the next slide. So we looked at 4 buildups, right, of what would achieve strength for this is for a building. You have a 3¼ over 3 lightweight as an example. You have a 4.5 over 3 normal weight, which would give you a fire rating intrinsically. And then you have options that go thinner with normal weight that would require us to spray the deck. And we used that and ran all sorts of permutations on loading assumptions, grid assumptions, and then these metal deck assumptions on that same example building. And if you treat the baseline building as our default of that 3.25 over 3, we were at, everything centralizes back to a 0% change. And as you can see, as we shift to normal weight, the carbon has gone down anywhere from 6 to 20% in the overall gravity system of this building. And the cost, which I've plotted on the horizontal axis based on cost metrics I was able to get that include spray fireproofing and things like that, suggests that the cost changes aren't nearly as proportional as the carbon changes. The extra cost is coming from a bit of extra steel costs because the system is heavier. But sometimes that can be made up for if you get better pricing on normal weight concrete than lightweight. And you are paying about like $1.50 a square foot to use spray on the metal deck. But this showed me that like if we open up this world to normal weight concrete as our standard for metal decks, then it opens up a lot of savings. And so we started to apply that to projects. So if you go to the next slide. So this is that National Geographic project. We were sort of doing this research as we were in CDs for National Geographic. And at 50% CDs, we had the sort of 3.25 on 3 that I was describing. And then what we did is said, we think this is the right thing to do. We think we should change the spec at 50% CDs and resize our steel. And we ran through those 3 options sort of at a high level and presented them to the client. One was 4.5, one was 3.5, one was 2.5. And in doing so, the architect realized, oh, we actually have a lot of 1-hour spaces, which 3.5-inch concrete will offer. So we don't even need to spray everywhere if we switch to this. And if you go back, sorry, in the process, we actually saved some steel tonnage and reduced the carbon of the project by 10%, just through that one change of specifying a different weight of concrete. If you go to the next slide, we did the same thing on that Bon Vigio project in Mexico, where we explored sort of the 3.25 over 3 versus the 3 on 3 using lightweight and normal weight. And this was a steel diagrid building, had very long spans. You might expect different outcomes. But again, it sort of held up. We added 1% to our steel costs in tonnage, but we saved 10% of the carbon by making that switch. And if you go to the last one, this one I think is particularly interesting. Sorry, the reference there for Office Tower Mexico is incorrect. This is an academic building in Detroit. But this building actually thought of using timber hybrid, gypcrete and CLT over steel at its inception for the sustainability story and for the aesthetics. But what we found is we haven't quite vetted a composite system yet that gets composite action for steel with a timber deck. And if you were to compare that non-composite timber hybrid option to a lightweight concrete option, yes, these steel, sorry, go back, please. The steel tonnage goes way down in the lightweight concrete option, but the carbon is way higher. It's about 33% higher than the timber hybrid option. But when we think about it with a normal weight concrete deck, we still get the benefits of the steel tonnage savings by having composite action. And we've reduced the carbon of the slab by 60 to 80%. So it becomes very competitive from a carbon perspective as the timber option. And so the project ultimately went with normal weight concrete over steel beams because it was a lot cheaper than the timber option. Just by looking at the steel costs alone, you could arrive there, but timber versus metal deck was also a cost savings. And we were generally achieving the same carbon savings as the timber option would. And so those are just a few examples of sort of how we approach this systematically and methodologically. We approach this problem on all of our projects and sort of try to seek design solutions to embodied carbon. And that's it for me. Thank you.
Thank you, Jordan. really great case studies you shared there. And I'm going to apologize for my mouse getting a little click happy on its own. I honestly wasn't even touching it. So with that, we can open it up to Q&A. So if anybody, we have about 5 minutes here to do that. And so if anybody has any questions, please pop them into the Q&A chat. I'm not seeing any in there currently, but I do have a couple questions of my own that I was going to share. If you bear with me a second. And so, one thing we talked about here a bit was the concrete and, this cement materials. What can we do to work with our contractors to get better materials, whether it be concrete or otherwise? I know sometimes we've seen roadblocks on our own projects when we've tried to specify lower carbon concrete.
Yeah, I think it's I think there's a multitude of factors that kind of get in the way. One is I think like I said in the presentation is like not requiring EPDs, in your specs, right? It's like if you want low carbon concrete, you need to require some like level of GWP limit to your mixes, and then we can actually go out there and ask for bids that include not just cost but also EPDs for these low carbon concrete mixes, and then we can actually make sure that those are actually getting into the building in a way that is cost competitive to the project. And also, if it's in the specs, that is something that we can then include in our estimates and in our costs and our GMPs, so that the project is, there's no surprises, I guess, as the project goes along.
To build off that too, Jacob, I think it's really great what we found successful is in our scheme or concept design report, we say this is what we're going to do. It's not a surprise to anybody. You should be costing it from the get. You should be starting to explore how you're going to do this. I think we've been generally like different project managers have different confidence in going out and saying, I want to do this because they're worried about cost. And what I've told people is like, ask for it. If they come back and say it's a premium, sure, but don't ask them for the premium. Don't put it as an adult. Just do it and let them tell you it costs more money. Don't ask for an ad because then it will be an ad.
Yeah.
So just go ahead and do it and let them explore, and then give them the freedom to tweak the mixes as they need to see fit to hit those targets.
Sounds great. Well, thank you all so much for your presentations today, and all of the speakers that we've had all day. It's really great information and case studies and tools that we can all work towards and look at how we can help the climate issue that we've got going on right now. With that, we're going to conclude session 4, and I'm going to turn it over to Jennifer Goupil to do some closing statements before we do our networking session. Thank you all.
Wow. Hello, everyone. I can't believe it. I learned so much, and I expect you did too. As Andrea mentioned, I'm Jennifer Goupil, the Managing Director of SEI, and I'm back again to bring us to a close of our fantastic symposium. Thank you so much for attending. We hope you have a new sense of confidence to understand some of the policies, how to navigate codes and requirements, how to communicate the value of sustainability, and how to utilize financial tools for your projects. Before we close out and head our separate ways, I have a few things to share with you about the good work that's ongoing. But before we even do that, I wanted to take a cue from 2 of our speakers, Orla and Alex, and tell you a story. So my origin story began in sustainability. I'm a structural engineer by training. I practiced for 10 years, and the way that I became involved in SEI was a colleague asked me to join the Sustainability Committee. That was early on. That was a long time ago. But I had my start here in sustainability. I feel very passionate about it, and I'm glad to see so many of you on the call. So now I would like to go into some of these upcoming SEI events, and I invite you to please stay engaged with SEI, our community, and our committees, especially the SE 2050 movement. Please join us. I want to specifically invite you to attend some upcoming events. First, you'll see our SE 2050 Summit is scheduled for April 29th at Structures Congress in Boston. This pre-day event will continue the critical learning and networking we started last year in Boulder. The Embodied Carbon Bootcamp is scheduled on June 11th and 12th at the University of Cincinnati in Ohio, moving to the Midwest to attract new learners to our community. Our Towards Zero Carbon Symposium will be coming back for a third time. Following the success in Boston, then in Boulder, this year we will convene in London on November 5th. SEI is partnered with the Institution of Structural Engineers in the UK, and as part of our collaboration with them to advance our shared goals on carbon reductions, SEI will organize our Towards Zero Carbon Symposium as part of iStructE's Sustainable Structures of the Future conference. The symposium will be a hybrid event, and you're invited to join us either in person in London or online for the symposium. Attend either way, but you will not want to miss it. Finally, I want to plug some events that are being planned for 2027. We hope to see every one of you in person at our very first ASCE 2027 conference, which is now being planned for March 1 through 5 in Philadelphia. As you all know and love Structures Congress, it is joining forces and becoming part of this brand new event. The call for content is currently open for this brand new experience and will close on March 4th. So let's get our message out to the designers and builders of all civil infrastructure. Take our expertise to the full built environment. Submit your sessions before March 4th. Also being planned is the 2027 Towards Zero Carbon event. When we aim to bring back the symposium, the boot camp, and the roundtable all back together again in 2027. Those details are just underway, or those organizing that event is just underway, but we'll be able to roll out those details as soon as we're able. So for those of you here who have joined us today that are not yet members of SEI, please join us. Get on the mailing list, subscribe to our socials, be among the first to hear about our next adventures, including our next virtual symposium. This event, the third one of it, will be planned for early next 2027, next year. If you are a member and would like to become a part of putting these events together, like the one we did today, we invite you to apply to join an SEI committee, either the SEI Sustainability Committee, the SE 2050 Committee, or our new task committee Towards Zero Carbon. Those folks are charged with charting the roadmap for our collective success. If you're interested, drop us a note and learn more. Finally, all the sessions today were recorded, and the videos will be posted within a week or so on SEI's YouTube channel. We will send you a link when those are up, as well as a survey asking you for your thoughts. Please participate in our survey so we can keep bringing you the innovative and needed content that you want. Additionally, be sure to check out the useful resources from our SE 2050 and Sustainability Committees, especially on materials and data, as well as the addition to the Circular Economy Case Study Database. All of these resources and more are found online at se2050.org website. Okay, one more slide, and this is the last one. I would like to thank the many, many talented and experienced speakers who joined us today. Thank you so much. I would also like to thank the SEI Sustainability Committee, especially our superheroes who pulled this off today, Brenna Marcoux, Suzanne Robinson, Shayna Saporta, Andrea Reynolds, and Sean Agostino, who organized this symposium for you all today. Give it up for those guys. Let's see some chats and or hearts and claps in the chat there. And many thanks to our resident superhero on staff, Bianca Augustine, for executing on the committee's vision. And thanks to you all for joining us today. You are the superheroes on the ground, doing the good work and making a difference every day. So that's it for me. But hey, don't be a stranger. Reach out on LinkedIn, drop us a note and email. I really want to hear from you and really understand how SEI can help. And with that, we're ready to conclude our second SEI Sustainability Symposium. Thanks so much for joining us today. And if you're staying on for the networking session, hang on. You'll be sent automatically to your breakout room, so just hang tight. If you're not networking with us today, thank you again so much for your time. We hope to connect with you very soon. Have a great rest of your day, everyone. Bye now.